Okay. Thank you for that. Started recording. Fine, right? So this is how a TestNG framework does. So this is one of the primary examples or primary purpose of reflection, right? We use reflections many times without us even realizing. Maybe I'll show 2 3 examples. Before that, I just wanted to touch upon few important things in reflections actually. Uh, let's say we create a new package. Uh, okay, okay. Let's create a main method also. Let's say you are creating object for this class itself. Let's say I am having some variables like int a is equal to 0 or something. Okay. Let's say we are creating an object for this test reflections itself. So what I'm going to do, I'm just going to use this method called get class. So if you see this description, it says return the runtime class of the object, and it is of type class actually. If you can see, it's of type class actually. Actually, if you see here, um, there is an class of the name class itself. Okay, class actually. So this is a common type which is Java itself is providing for us. Now, the primary purpose of this class is actually to get the property of any class and assign to it. You see whatever this is a test reflection, this is a class which is created by us, but it is of what it's of type class itself, right? So to represent class itself as an object and to get its properties, we have this class itself. Maybe we'll see some example. So what you'll do, if you click a dot here, it will have list of methods that are actually present there actually in the class. So let's say I'm getting this get declared fields. Maybe I'm trying to what's return type of this. Return type is the field itself, right? Java.lang.reflect field. So what I'll do, I'll just try to get this field is in an array. Let's try to run this. Okay. Now it's printing, right? A. What is this A? It is the A which we declared here, right? Let's have one more. Try to run this. So now we are able to get the runtime property or runtime. In the runtime itself, we are able to get the properties of this test reflections class itself. Right? So similarly, this particular so if we go and see this particular field extends this accessible object implements the member class. So what it will do, it has many functionalities which you can perform over the particular field itself, right? So if you can check what type of the field is that, okay? So you can get the type also, right? You can check if it's a generic type or not. You can check the equality of the particular field with something which you wanted to compare. You can check hash code. We'll come to hash code. What is an hash code? So similarly, like field, we have this method also, method annotation. For example, let me create one more method in this class. Let's say, so we had this field thing here. Similarly, we can get the methods also. To get the method, we have this something called method class in java.lang.reflect package. Let's say declare methods. So I'll just iterate it again. Okay, let's say we get a return type in the print. Try to run this. So now there are two methods in our class, right? One is a main method itself, and the second method is this particular return arbitrary name. So the both the return types are printed. One return type is void, other return type is it is fully printing the fully qualified name. Right? So what's a fully qualified name? The fully qualified name is something which is present along with this package name dot class name, right? So now we know it's of type string actually. Okay. Maybe we'll try to print some other thing also. We'll try to print name. So now we know what are the method available in the particular class itself. We'll try to do some other things also. So we can print this parameter count. What's a parameter count? What are the number of parameters present in each and every method actually, right? Now this entire method things are available as an array. So now you iterating through each and every method and getting the property of each and every method. What is its name? What are the type parameters? how many arguments are there, everything we can get that. This main method has one argument, and this particular return arbitrary name has 0 arguments. Right? Now through this you can do this. But I have also one more special thing which I can do over the method. It's like I can invoke the method, right? Actually, so what I'll do, let's say if m dot get name dot equals uh, I will say m dot invoke. So what object I want to invoke, this is the object. And I don't have any arguments to be passed for this object. Now it will throw an exception. Uh, so it throws illegal access, illegal argument, illegal invocation target exceptions, right? So whenever you see this invocation target exception, it means that the particular method which you are trying to invoke, or particular class which you are trying to get, is invoked through this concept of reflections, actually, right? We'll try to invoke this. Let's say I don't want to do something because it doesn't know what is the method. Maybe I'll try to do this out here. I'll try to execute this. Okay. So it means that the particular method is invoked. Right? We definitely know for sure this method is called no, right? So because we have printed something in the console, to get its return value, again we have to cast the particular thing to string. Maybe we'll see this in a later point. But the idea is that you can invoke a method using the reflections like this. So what if I wanted to pass an argument here? I can do that also. Let's say I am passing some string here itself. String, say a, and I just print the string along this, right? With the space. So what I will do, I just pass an argument here. Let's say so now the method is invoked. Reflect will be printed in the console. Let's see. Okay. So now it's accepting that argument also, and it's printing. So you can pass any number of arguments here. There is something in Java where you can get to pass this n number of arguments actually. I'll show that actually. So you have these 3 dots. Have you seen any type of arguments with these 3 dots actually? Mithun or Vinay?
No, Karthik.
Okay.
Okay.
Okay. What does this 3 dot means? You can pass any number of arguments. There are no such thing like you should pass only 2 arguments or 3 arguments like that. You can pass any number of arguments. It's not only with respect to object. It can be a string also. For example, let's see. You can even let's say I'll do it here itself. Let's try to run this actually. Okay, sorry. I think you have to pass this as a. Okay, we don't want to do this in this example. Maybe you're trying to access through reflections, right? I'll show in a separate example itself. This one. Maybe we'll create a new class. Say I have a method here. Let's try to run this. Okay, I think it's printing the entire thing itself. Okay. So what is the purpose of this particular three dots is like, see, in Java, any argument that you pass, right, must be well defined. For example, see, you are having these two arguments in this particular process in this particular thing. If you go to this invoke method, I'm not able to go to show this. It will accept two arguments only, right? So everything is kind of defined in a compile time itself. So if you create a method with the three arguments, then you should pass any. You should call the method using those three arguments only with the same type also, right? We saw this when doing the Java sessions also. But what if there are some scenarios? What if we don't know that how many number of arguments that are actually there that we are going to pass to a particular uh, thing as an argument to a particular method? We don't know that. So in this case, we can use this three dots to say, hey, I'm going to pass infinite number of arguments here. I don't know exact count of arguments. So you can access this each and every argument through its index actually. Right? If you try to access the index of two, it will throw an error actually. So it is showing array index of bound of exception, right? So yeah, we are. It is like we are actually getting the list of strings as an array. So how many strings we pass, the same number of strings will be passed as an array here. Just that we don't have to declare the size of the array at the beginning itself, right? It's very useful in these kind of scenarios. So you're getting the whole point, right?
Yes, correct.
Okay. So this can be okay. This can be used in multiple ways. Actually, if you try to explore these things, it is very useful. Actually, not only with respect to string, you can use it with respect to anything, with respect to integer or anything. You can try to use this, right? So okay, now we know we are able to get the fields. We are able to get the methods. We are able to call the method at the runtime itself. So why we need something like this? See, for example, we are saying T dot the same. We are creating object tr for this test reflections class only, right? And we are saying tr dot get class and get declared methods, right? And each and every method that is present in this method array. And why we have to again pass this object as an argument to invoke that method or to call that method actually. Any idea?
Both of them.
So there is something called type safety also, right? See, we are just invoking a method. This method is a very generic term, right? See, method is something which is used to represent the methods of any class. It may be any class. We don't know what are those class. Even though we are getting the method from this object here, this where we are assigning this method to, we are assigning this method to a very generic method array. So at the runtime, we don't know what class is that. So we also have to include what object in the argument so that we know for sure the particular method that is going to be invoked is of type test reflections. Then what this particular reflection will do, it will go and search for this test reflection class only to invoke this particular method. If the particular method is not there, it will throw exception, invocation target exception. It throws, right? It throws this invocation target exception actually. So this is the main purpose we are passing this TR here. Even we saw this one example of reflection in the previous class itself. We saw this. Anyone attended the previous class actually?
Yes,
We
sir.
saw this page
Yes,
object model, right? We saw this init elements. What it will do, it will allow us to initialize everything at the compile time itself. We don't have to initialize this separately by saying web element is equal to driver dot find element like that and all. You can just annotate this method with web element. Web element with this particular find by with whatever locator which you wanted to do. Name in this case, XPath in this case. And even here, we can do something like this, right? We can just say, this is a forms the class which we created here. And we can just say form dot. You can call the method directly like this also, right? If you see, we didn't say, hey, form is equal to new form and all. We just say initialize the elements of the page factory class form. So we are able to call this method fill form, which is available in the form class itself. Generally, what is the notation to call an particular method? Form, new form. So this is the actual thing which we wanted to do, right? Okay, the constructor is undefined, but generally this is the format which we'll try to do it. But without doing this actually we can directly call this method like this. Also, it is because this method is invoked through reflections here actually. If you go to this init elements of implementation, see, if you go to this init elements, it accepts this second argument, which is of type class itself. We saw this class object, right? So, class thing, right? In Java.rank. Classes. So, what happens is like you can pass any class as an argument. Here, this example is form.class. You might have login.class. You might have careers.class. Anything, any class you can pass as an argument. So how you are accepting this class as an argument? Through something called class itself. Right? So what does this T represent? It represents it should be of type the class itself. And it's a proxy, right? It's a proxy because proxy is something which we have an worker to do same work instead of the main thing to do, right? We just assign a proxy to do a work. If I wanted to do some work, I will just manage, hire somebody to do that work. So he's a proxy for me actually, right? So what happens? Whatever the argument we pass as a second argument, it's a type of class itself, and we are instantiating the page by passing this argument. Right? So if you see this constructor, it's java.lang.reflect constructor. You can see here. So what we are doing, we are getting the constructor of the particular class itself actually, right? And we are creating a new instance, right? We are creating a new instance by passing the WebDriver as an argument. So now we have created an object indirectly, not directly, but through reflections. By getting the constructor, we are creating an object itself. Okay. Now we have got that object in this particular object called page. It is returning that particular object itself. Right? Return constructor.new instance. So it is creating a new instance of the particular class itself and returning to this object called page. We are calling this init elements, and we are passing the driver and page. What is there in this init elements? We are just initializing the driver. Sorry. And we are, if you go here, okay. So now what it will do, it is initializing the particular element factory located. Actually, this particular class is available in the Selenium package. It is initializing the particular element locator and initializing all the particular fields which we asked to initialize using that find by annotations. Actually, that is the thing which is done here using something called field decorator. So what are the fields that is available there? It will be invoked and initialized based on the annotations that are available there. Right? Again, we call the same thing here. Again, what class that we are going to process, and we are just getting the proxy fields for each and every field present here. We are just setting the value for that. Right? We are getting the field. We just saw this field example, right? We are getting every field present in that particular class, and we are initializing the particular field to whatever annotations that are present there. Right? So this is a very classic example of reflection actually. So reflection is kind of used everywhere. In many frameworks, you can see these reflections kind of very helpful to achieve many things in the runtime itself, because this page factory.init elements is very generic actually. Right? We don't know what class we are going to pass here. For the particular class, we have to initialize all the variables and we have to call all the methods available there, right? So reflections is kind of very helpful there also. Fine. Okay. Now we'll come to our actual thing. Actually, why we want to use reflection in our thing is like, so we have this framework, right? We have this many types of framework called keyword, data driven. So what's a keyword driven framework actually? Any idea?
No, Karthik.
So there are different frameworks that we can use. So we have keyword driven, data driven, and hybrid. So that common example. So keyword driven framework is like, see, for every test automation that we want to run, we just have to call some methods available in our framework. So one method may be login, it accepts username and password as an argument, and it goes to the page and puts username and password in the form fields and click on login button. And second method may be validate something in the home page, etc. And third method may be logout. Let's say we have three methods to test out test case. Login method, validate home page, logout method. Logout method clicks logout link and check that logout successful page whether that is displayed or not. So we have these three methods. Let's say we have this login method, validate home page with logout method, each having separate pieces of code to do this respective functionalities. So there are many ways that we can invoke this method. For example, let's say I have this test case one. To do this particular functionality, right? So this test case one should call these three methods. There may be another test case called test case two, which may call another again another three methods. There may be login method as well. Login method is common. Let's say in this test case two, you want to validate about us page, and again you wanted to validate some carriers page, and so on. So these are two different test cases which call separate methods, sequence of methods. So how we are going to call these methods defines a framework actually, right? In what way we are going to call these methods in our automation framework defines everything, right? What's the framework, what's the structure, and all. So example, let's say I have an Excel sheet. Let's say I have an Excel sheet here. Let's say I have this test case one here. I have this data, everything here. Let's say I have a login, validate home, logout. Let's say you have this test case one, login, validate, and logout. All these three are exact method names which are actually available in your any Java package or any Java class. So when we are driving these methods from the Excel sheet, then we call as keyword driven framework. Getting it right. That's a keyword driven. When we are driving what method that we need to call from the Excel sheet itself, then we call that as a keyword driven framework. Is that fine? What's the keyword driven framework example? So if you wanted to execute this test case one, if we say a framework to execute this test case one, okay, just give me a minute, okay? Okay, sorry. So we'll continue. So if we wanted to execute this test case one, what actually happens is like three methods in our Java project will be called. There is a login method, there's a validate home, logout method will be called actually. To say this particular execution is passed or failed. You're getting the whole point, right? Why this is called. So this is a keyword driven framework, right? We are driving everything from Excel sheet. Why is a keyword driven? Keyword is a method name. It's driven is something we are driving that method, calling that method name thing from an external source like an Excel sheet. If you are driving something like this, it's called keyword driven framework. Find.
Yes, correct.
We'll see how we'll implement maybe tomorrow, but I just wanted to give the heads up of reflections and how to do this. So can you see how where this reflection fits in this keyword driven framework actually? Where does this reflection parts comes in the keyword driven framework actually? See, we saw what's the reflection. Okay. We saw what's the keyword driven framework. So where does this keyword driven framework fit into reflection theme? Can anyone say? It's a very simple answer, right? Anyone try to say?
I think it's while we try to access the methods in the Excel sheet.
Okay. See, we are. See, let's say we have this Apache Poi library to read data from Excel sheet. Right? Let's say I have this test case one to be executed. I'm just going to read all these columns and put it in a string array. Right? What the purpose of doing something is to call these methods actually. So we don't know. See, we cannot go and change or modify the code at the runtime to make our code create a new object and for this particular class and object.login or object.validate or object.logout. We cannot do something for every method that is available present in our every class, right? So what we can do, we should invoke this method using reflections actually, right? So we have to read the particular test case and we have to read what are the method names that are given against this test case, and we should read it in the Java at the runtime. So we should invoke this method, like whatever example we saw in this reflections example, right? We should invoke this method like this at the runtime using reflection. Right? So you're getting the whole point. So I'm invoking this particular. I'm maybe I'll just collect. I'm iterating and putting everything in the put everything in this main method array. So I'll iterate for each and every array. I'll invoke the particular method. Right. So in this way, if I'm invoking using a for loop by iterating through this method array, where this method array get this methods from the declared methods. So we have to compare this method. Now I'm comparing this particular method name by hard coding in our code. But what if I replace this particular thing here with the data read from an Excel? If it's equal to the data that is read from an Excel, then you should invoke the particular method. So read the data method name from the Excel. Let's say this return arbitrary name method is from the Excel sheet itself. Right? So logout, I'm just returning some arbitrary name. So this method should be driven from the Excel sheet itself, read through Java code and replace it here. If the name matches, then invoke that method. So now we are getting the whole picture why reflections are needed in keyword-driven framework.
Yes, correct.
We'll see this example. We'll do it practically actually. We'll try to do it tomorrow. So this is why we need a reflection kind of thing. Reflection is actually very, very useful. It's used in many areas actually. And you can check out online for its applications. But the main purpose of reflections is to get any property of any class in the runtime and use its property to do something at the runtime. We don't know what is that property, what is that class at the compile time. It is all determined at the runtime itself. So in this example, in keyword-driven framework, it used to invoke methods available in the class. Uh, okay. Actually, we'll continue this thing tomorrow. The back of the session today, I just got some urgent work now.
Okay.
Okay. We'll continue to actually, implement this whatever we read from Excel and invoke the particular method from Excel. We'll continue to do it practically tomorrow actually. Right.
Okay.
Okay, good.
Thank you for joining.
Okay.
Thank you, sir.